The topic we are going to discuss is synchronous motor. Now, what is synchronous motor? A synchronous electrical motor is an AC electrical motor in which at steady state the rotation of shaft is synchronized with frequency of supply current. That is, the at steady state time t is equal to 0, the rotation of shaft is same as with the frequency of supply current. The rotation period in this synchronous motor, the rotation period is exactly equal to integral number of AC cycles, that is n is equal to 1 2 3, the number of cycles, which is exactly equal to the rotation period, the which in which the shaft turns or rotates. Why this is called as synchronous motor? Because they can operate at only one speed, that is the speed of rotating field. The speed is constant, it never changes in this. There are so many other motors, but these synchronous motor are more efficient than all other motors, especially induction motor, because these motors power factor can be varied, whereas in induction motor power factor always runs lagging. Synchronous motor is most common three-phase motor. Okay, what does it do? What is the function? What all does this synchronous motor do? Let's see. This synchronous motor, when connected to three-phase electrical conductors, these are placed in a certain geometrical position and at a certain angle from each other, which helps in generation of electrical fields. By placing in a certain angle, these motors produce an electric field. Then the rotating magnetic field rotates at a certain speed due to the presence of electric field. So that speed is known as synchronous speed. Then the next point is the electromagnetic is magnetically looked with this rotating magnet field and rotate at the same speed as the rotating field. So this is why we call this type of motor is called as synchronous motor, as the speed of the rotor of the motor is same as the rotating field. Now let us look into brief about the construction of synchronous motor. This synchronous motor consists of yoke, stator, DC excitation, armature winding, rotor, three-phase supply, and rotor windings. But the synchronous motor is generally made up of two parts, mainly two components, a stator and the rotor. The stator, which is a stationary part, it won't move. This is stationary. That carries the armature winding in which the voltage is generated. The stator is the part where the voltage is generated, and the rotor, another important part, that is the rotating part of the machine, which produces the main field flux, that is the magnetic flux. Rotor produces the magnetic flux. Now let us look into the working principle of synchronous motor. After looking into the construction, we get to know that rotor and stator are the main important parts. Now let us look into the synchronous motor working principle. The working principle mainly depends on the interaction of the magnetic field of the stator with the magnetic field of the rotor. Thus, we get to know that rotor and stator are the important parts where the interaction of magnetic field leads to the working principle of this motor. The stator contains three-phase winding and is supplied with three-phase power. Thus, stator winding produces three-phase rotating magnetic field. Thus, DC supply is given to the rotor, not AC supply. DC current is given. The rotor enters into rotating magnetic field produced by the stator winding and rotates in synchronization. Now, the speed of the motor depends on the frequency of the supplied current. The frequency of the supplied current is the main and very important factor which controls the speed of the synchronous motor. Thus, the speed of the synchronous motor can be calculated as 60 F by P or 120 F by P, where F is the frequency of AC current calculated in Hertz, P is the total number of poles per phase which is present in the synchronous motor. After we get to know about the principle of the synchronous motor, we will know about the let us see about the some of the application about the synchronous motor. These applications are mainly due to the constant speed in the synchronous motor. The applications are ball mills, used in ball mills, watches, clocks, record players, turntables, robot actuators, fans, blowers, and pumps. These are some of the application of synchronous motor. Now let us look into the types of synchronous motor. There are two types of synchronous motor: non-excited synchronous motor and direct current excited synchronous motor. In non-excited, they are subdivided into three types. Let us look into it later. Now let us look into non-excited synchronous motor. This type, the rotor is made of highly retentively steel such as cobalt. At synchronous speed, it rotates with rotating magnetic field of the stator, so it almost constant magnetic field through it. There are three types of synchronous motor: hysteresis synchronous motor, reluctance synchronous motor, permanent magnet synchronous motor. The first one is hysteresis synchronous motor. These motors are single phase motor with the rotor made of ferromagnetic material. Since it is made up of ferromagnetic material, they produce high magnetic field which helps in the motor running. The rotors have high hysteresis loss property. This has high hysteresis loss property. That is, a hysteresis loss property is a property of a ferromagnetic material. Next, reluctance synchronous motors. This is always a minimum when a piece of iron rotates to complete magnetic flux. This reluctance increases with angle between when the poles are aligned with the magnetic field of the stator. Next, third type, permanent magnetic synchronous motor. It uses permanent magnet steel to create constant magnetic flux. The rotor locks in when the speed is near the synchronous speed. Next, the second type of the synchronous motor is direct current excited synchronous motor. This requires a DC supply for the rotor to generate a magnetic field. This has both stator winding as well as rotor winding. The construction is same as the previous one. The direct current can be supplied from a separate DC source or a DC generator connected to a motor shaft. This is all about the synchronous motor, its application principle, working principle, construction, and types. Thank you.